It can actually be helpful to think of cloud in a sort of layer model, with services which can rely on layers below. So different vendors, for example, there's absolutely no point in as Dominic was saying earlier on, we want to enthuse the vendors to actually start working in this kind of way. But there's absolutely no point in them doing that from scratch. Broadcast vendors like to do everything themselves, but there's no point in them building the server infrastructure. There's no point in them building the networks to support this. The layer model basically allows them to rely on other people who have got economies of scale and can do that kind of thing far better than they can. At the bottom of the layer model is the actual physical service. So one of the things to remember every single time that you interact with a cloud system is you can often get into the mindset of thinking that it's out there on the cloud. It's not. It's on a physical machine somewhere. You might not know where it is. You might not even know what continent it's on. You won't know what operating system it is, and frankly, you don't often care. But you will somewhere be running on a physical piece of hardware. So that's the kind of server layer, and there are a number of companies who provide that kind of layer as a service to higher level companies. Example would be Pier 1 in London, which was the host that we used for our trials. This thing's gone to sleep again. Okay, so the second layer in the model is infrastructure. So this is basically where someone provides a bit of an interface over the top of those physical machines. Typically there'd be some sort of web interface. It's often referred to as an IaaS service or infrastructure as a service. And I think we could do with some cloud-based stuff here at the moment. It's often sold as a utility or a service. So you're not buying a server at $30 for a month, but you're buying so many hours of CPU time, so many megabytes of data transferred in and out of the platform. An example would be ElasticHost in London, but again, there are literally hundreds of different companies providing those sorts of services. The next layer is the platform layer, and in this we get what's called PaaS, or a platform as a service. And in these kind of solutions, you tend to see a solution stack delivered. So we'd integrate things like database and provide other tools that might be useful at that layer. So in a broadcast context, that might be somebody providing a stack that provides things like transcode, asset management, and other services that higher level applications can then call on in the model. An example of this in the IT world would be Microsoft's Azure platform, which is a kind of cloud-based system, but where Microsoft provision out actual databases and chunks of their server technology as a service. The application layer is where probably most of us have had our experience, often known as software as a service or SaaS. And there's no install required. So you're using a SaaS service when basically you go to a web browser, you travel to a site and you get something that looks a bit like an application, but basically it's running within a browser. There are other techniques where it actually has the look and feel of an actual application. But basically the software is never installed on your local machine. And it's a simple pay and use. So we've all come across Google Docs. It's a perfect example of this technology. Anyone that's using Salesforce, it's again another technology. And Salesforce themselves, they don't provide the platform, the infrastructure, or the servers. They just buy all of that wholesale from other suppliers. So this is basically the way that this kind of model is panning out in the IT world. And then finally, you get the actual clients themselves. So these are typically devices which completely rely on the cloud to operate. So there's actually certain mobile phones and things now where all of their applications are not stored locally. They're actually downloaded and streamed as and when they need them. There's actually huge advantages to this kind of thin client approach, because if you imagine you've got an organization with 200 PCs with an asset management system running on it, and you decide that, or the asset management company decides they want to upgrade it, that's actually quite a lot of work for someone to go around and upgrade all those machines. With a thin client approach, you upgrade your server and then everyone hits F5 and that's your software rollout done. Corporate portal would be a sort of example from the IT world. So what exactly are the benefits to using a cloud-based platform? I think, as we touched on earlier on, disaster recovery has to be, I think, the most immediately obvious application of this kind of technology. So if you imagine today, one of the biggest issues facing any kind of cloud infrastructure, particularly in this part of the world, is latency of access to bandwidth. So generally the thing that tends to, you can normally get fairly large bandwidth, as Bevan was saying earlier on, if you really want it and you can afford it. Large amounts of bandwidth wherever you are in the world are generally available one way or the other. But it's latency that gets in the way. And latency will always limit what you can do. But disaster recovery, if you're in a disaster recovery scenario, you may actually be willing to put up with a lower bit rate or a lower quality. Perhaps something like 2 megabit MPEG-4 might be acceptable during a disaster recovery situation. At least your adverts are going to go out on air, or if you're a state broadcaster like the BBC, at least your content's going to go out on air and keep your viewers happy. And initially, it's a risk-free way of kind of investigating the technology. So you can imagine a scenario where you install an agent on your TX server and you make a low bitrate copy which gets posted up to the web of every asset, every MAT-ID'd asset that comes onto that video server. And then basically you take a sniff of your schedule and you run that schedule on the cloud. And so you've always got two systems that are roughly in step with each other. And in the situation of worst comes to worst, like OSN's recent fire, you're in a situation where you've got something that you can rely on and go back to. And then once the situation has resolved itself, you can come back. The other alternative is that you go for a model where instead of having the same content, you actually go for evergreen content. And in that situation, you can actually afford to put those clips up onto the cloud in the very best quality, because time is not a limiting factor in those kind of situations. Redundant clouds can also be dormant, as we said before, so they don't actually cost anything until they're required. And if you contrast that today with the kind of massively expensive DR projects that we as TSL have been very privileged to do, and I'm very glad that we did them, but some broadcasters spent huge amounts of money on DR because this technology wasn't available 3-4 years ago when we did those projects. But it's an interesting contrast and one that we have a choice on today. Additional channels, low-cost channels, is another area where I could see this technology being used. So a good example from the UK market would be something like the Wimbledon tennis championships, where there are literally hundreds of games going on at any given time, and different people are interested in different games. Now, some of that is serviced today on the internet, but people still enjoy a linear channel, and the BBC is often looking for additional bandwidth to allow them to run those interactive services and those services which provide the additional games, but they don't have they don't have the money to invest in that infrastructure for a one-off event. Something like the cloud really helps in that environment, because you can scale to a large number of channels and then scale back again and deal with it that way. So I think additional channels is another area. I think, as we said before, the community cloud model shared with other broadcasters is able to help reduce the risk. Perhaps common disaster recovery is an excellent candidate here, because we can provision out a situation in a cloud-based environment where, even in a catastrophe where, say, 3 or 4 broadcasters lost their facilities simultaneously, in a cloud environment you can scale those resources in a way that you wouldn't be able to do with physical assets. For companies that actually do deploy this kind of technology, they're going to have an interesting situation on their hands. It was interesting to hear Nick saying earlier on that he was a bit concerned that we might all lose our jobs over this. And I think he's right. I think we're on the cusp of a sea change within the industry. We've all been talking for a long time about how important IT is, and lots of us are working in organisations now where we have dual IT and broadcast departments that work hand in hand. But this kind of shift towards a generic IT infrastructure is going to mean that we find ourselves, if we're a simple playout operator, in a situation where our IT components are actually being managed by perhaps a third party, or being managed by our IT engineers within our own company. And it's actually the software that then becomes important. I'd be the first one to admit that we wouldn't want IT engineers looking after broadcast software. We want people who are trained in broadcast to look after those broadcast pieces of software. But it becomes less of an issue of software and hardware and more of an issue of where those engineers sit within the overall structure. Inevitably, there's always a piece of software in any installation which gets left behind on the development map, sort of legacy software that we all come across. We can't do without that particular piece of software. Often it's a very simple application, but no one wants to replace it. In those kind of scenarios, a cloud-based environment really helps because, as I said before, you can build isolated virtual machines. So you're not just limited to running today's operating systems like Linux and Windows Server, but you can actually run yesterday's operating systems as well, and you can do it in a safe environment. So you can run Windows NT, Windows 98, Windows 95, anything that's run on an x86 platform over the last 10, 20 years of development can be run on those kind of systems, but they can be run on modern hardware. So that's a third issue that helps with the compliance. So in conclusion, this doesn't want me to conclude. There we go. It is a polarizing technology. I've been speaking about I've been using the technology since 2000. Did my first virtualized project around about 2003, 2004 at the BBC. And I've been talking about it at IBC and various other places. And it's only in the last sort of year or so that it's really started to gain momentum and people have started to realise it's a serious technology. It's really encouraging for me to see 5 or 6 senior guys from this part of the world all saying, yes, there's issues with it, but it's a very interesting technology and we want to look at it further. What is certain is that it's already had far-reaching implications in the IT industry. It's done nothing short of revolutionising the way that IT managers build their systems and manage them and support them. As we're able to see earlier in the presentation, there are certain tasks today which cloud computing is just not appropriate for today. Particularly things that are reliant on hardware cards or high CPU usage, things like that. But as we move closer and closer towards what I tend to refer to as a stream-based workflow, so where we're not passing things around using BNC, but we're passing things around as streamed files. As we move closer and closer to that, we'll start to see the validity of a cloud-based model verified right across the whole of the broadcast workflow, whether that's an internal cloud, an external cloud, public, or